Waalaikumsalam warahmatullahi
Waalaikumsalam.
wabarakatuh.
Selamat pagi. Eh, Alhamdulillah kita bisa berkumpul kembali ya dalam keadaan online begitu. Mungkin beberapa masih baru dengan saya, beberapa mungkin sudah tampak familiar begitu ya. Beberapa sudah pernah ikut di kelas saya sebelumnya. Baik, ya. Oke, jadi ini kelas analisa numerik ya, analisa numerik untuk kelas Y, betul ya?
Iya, Bu.
Iya, Bu, betul, Bu.
Baik, ya, jadi karena ini kelas Y, nanti insya Allah dalam perkuliahan kita akan menggunakan bahasa Inggris ya di dalam perkuliahan. Jadi saya harapkan nanti semuanya juga berbahasa Inggris. Kalau seumpama ada kesulitan di dalam bahasa, silakan ya. Kalau memang sulit menyampaikan dalam bahasa, misalkan ada pertanyaan begitu ya, sulit menyampaikan dalam bahasa Inggris, bisa dalam bahasa Indonesia begitu. Tapi saya harapkan ini menjadi latihan juga begitu ya. Jadi latihan menggunakan bahasa Inggris terutama dalam keadaan akademik begitu ya. Jadi dalam akademik. Nah, nanti harapannya bisa academic writing juga begitu dalam bahasa Inggris gitu. Ya. Jadi sebelum kita masuk ke perkuliahan ya, mungkin saya perkenalkan dulu yang belum mengenal saya Vivin ya. Kebetulan semester ini diminta mengampu mata kuliah analisa numerik ya, dan memang biasanya saya mengampu mata kuliah ini ya, spesialisasi di mekanika fluida sebetulnya ya. Tapi juga karena background banyak di simulasi ya, simulasi numerik. Jadi memang sedikit banyak mempelajari tentang analisa numerik sebagai basis ya. Jadi insya Allah nanti dalam 1 semester ke depan saya yang akan mendampingi begitu ya untuk mata kuliah analisa numerik ini. Baik, ya sebagai ini di awal mungkin saya ingin ada grup ya begitu. Jadi nanti karena ini masih online ya, mungkin ke depannya ada kemungkinan, saya kurang tahu ya bagaimana rencana ke depan, apakah nanti ada hybrid dan sebagainya. Tapi karena ini masih mungkin sebagian online ya dalam perkuliahan ini, saya minta kita bisa koordinasi via WA. Jadi saya minta tolong dibuatkan WA grup begitu bisa ya? Mungkin salah satu. Iya,
Iya,
siapa
Bu.
ya? Oke, baik
Mungkin
Sultan ya.
ya saya buatkan grupnya.
Baik, terima kasih. Jadi nanti tolong dibuatkan grup untuk kuliah ini ya. Nanti saya tolong di-add juga. Dan nanti kalau ada apa-apa ya, misalkan ada perubahan atau misalkan ada tugas dan sebagainya yang perlu kita koordinasikan lewat grup, nanti kita akan lebih cepat begitu ketimbang ya misalkan lewat classroom begitu ya, by email. Baik, jadi itu ya terkait dengan koordinasi, kemudian juga terkait dengan pelaksanaan ya, ini kan dimulai jam 10 begitu ya. Nah ini saya ingin mengajukan begitu, kalau seumpama sedikit dimajukan gitu bagaimana kira-kira sekitar setengah jam, jam 9.30, kira-kira bagaimana?
Izin menjawab, Bu.
Ya.
Perkenalkan nama saya Jusia Menangan dari
Ya.
angkatan 2019, Bu. Untuk kami sebelum kelas ini ada kelas elemen mesin 2, Bu, sampai kalau menurut jadwal sampai 9.50, Bu.
Oh gitu, sampai jam 9.50 ya. Biasanya
Iya,
selesai jam berapa? Belum tahu ya. Tadi selesai jam berapa? Masih awal ya tadi?
tadi sekitar selesai jam 9.20-an, Bu, kira-kira.
Iya. Oke. Baik. Ya, mungkin kalau ini mungkin kita usahakan jam 9.45 begitu bagaimana? Biasanya kan kalau sebetulnya kalau 3 SKS ya, karena mata kuliah 3 SKS itu seharusnya 50 menit perkuliahan. Jadi seharusnya dalam 2,5 jam selesai begitu ya. Meskipun tertulisnya mungkin 10.50, tapi 2,5 jam mestinya selesai ya. Jadi jam 9.30 harusnya sudah selesai. Jadi kalau kita misalkan upayakan jam 9.45 gitu bagaimana?
Mungkin bisa diusahakan.
Insya Allah bisa sih, Bu.
Ya, baik, kita coba ya, kita coba 945 itu ya. Nanti kalau misalkan memang ternyata selesainya molor begitu, nanti kita coba lihat lagi ke depannya ya. Jadi insya Allah ke depan kita akan mulai pukul 9.45 begitu ya untuk perkuliahan ini. 15 menit lebih awal dari jadwal. Ya, jadi mungkin itu untuk pelaksanaan perkuliahan. Nah, ini kuliah analisa numerik. Coba sekarang kita akan masuk ke slide ya. Oke, baik. Jadi perkuliahan ini judulnya ya adalah analisa numerik. Ya, ada yang punya bayangan ya kira-kira atau namanya adalah numerical analysis. What do you have in mind when we talk about or when you heard the term of numerical analysis?
I think it's about statistics.
About statistics.
Yeah. And about mathematical equation that we put inside a computer program.
Okay, so it's about statistics and mathematical equations in which we can put it in a computer program. Before I say whether that is correct or not, I want to hear from the others. What do you think of numerical analysis?
I think it's about data processing.
It's about?
Data processing.
Can you repeat?
Data processing. Data.
Data processing. Okay, data processing. It's about data processing. What do you mean with data processing?
I mean, it's like it's actually quite similar with Sultan's answer. It is related to statistics, which we will be talking about data, and then the related to the processing terms that I said earlier.
All right. Okay. So almost similar, relates to statistics. Yeah, so it is about data processing, which relates to statistics and other processing method. Okay, almost getting there. What about the others? What do you think when you heard about numerical analysis?
Excuse me, ma'am. I'm trying
Yes.
to answer.
Okay.
In my opinion, the numerical analysis is like a mathematical model to solve the engineering problem. So there are functions there which can be input to some software to finish some engineering problem. Maybe that's it.
Okay. So there will be a mathematical model in which we can use that to solve a problem, and we can apply it. Yeah, we can apply it in computer software. Okay, so this is about mathematical model. So what is the difference, as you said before? Yeah, mathematical model. What is the difference with calculus? What is the difference with calculus? Or perhaps before Sultan, perhaps, and Krishnati, yeah, was saying that it relates to statistics. So what is the difference with statistics? Because you will get another course which is about statistics. So why do we have numerical analysis then, if it's the same to statistics?
Excuse me, I want to answer. Maybe before we talk about statistics, we need to get the data first. So the data is, we get the data from the numerical analysis from our experiment. Maybe like that. and we can analyze the data. We can analyze the data with a calculus equation, with a calculus that numerical analysis, we can do this with calculus, maybe like that.
Okay, so we can apply calculus in this analysis, yeah, numerical analysis. All right, so from here, yeah, it's almost getting there, but I think there's still no one can get to the point, yeah, to the exact point of what we are going to learn here about numerical analysis. Yeah.
Ma'am, maybe I want to.
Yes, Adim.
I think the numerical analysis is about involves discretization, ma'am.
Okay, it's about discretization. Discretization.
Yes, and then we must ensure the variable is finite. So we have like finite element method, ma'am.
Okay, so it's talking about discretization, and that can lead to finite element method. Okay, so that is correct. That is one of the example of numerical analysis. But what we are going to learn is not limited only to that. Yeah, so numerical analysis is a broad discipline in which we will learn many methods, yeah, about numerical. Yeah, so what is meant by numerical? Numeric means a value, yeah. And when we talk about numerical, is it different to calculus? Yeah, calculus is also dealing with numbers. But what is the difference between numerical analysis and calculus then?
Maybe I want to answer, ma'am.
Yeah, Farhan.
As said before by Adim, numerical analysis is using discretization. It means that the numbers value is only finite number, but in calculus, it's a continuous number.
Okay. So in calculus, it's a continuous value, yeah. And in numerical analysis, we usually dealing with finite numbers, yeah, finite numbers or finite data. Okay, so it's getting there. And what is the difference then if we have the finite data and we have continuous value? What makes it different?
Excuse me, ma'am. Is
Yes.
it about the programming?
Programming? Yeah, programming, you can do almost anything with programming, yeah, actually. But yes, correct, this is dealing with programming. But what is the difference, the key points, the key difference between numerical analysis and calculus? Or you have engineering mathematics, yeah? Matematika rekayasa. What is the difference between that with numerical analysis? So usually numerical analysis is also called numerical methods. Yeah, numerical methods. So it means that what we are going to learn is about methods. Yeah, so it's about methods. And the methods that we are going to learn is not very difficult methods. Yeah, so it's not a complex method, but actually a very simple method in which it's in the form of arithmetic operation, yeah, arithmetic operation in which it can be solved by the computer. Yeah, so if we think of how the computer works, yeah, how we do programming in the computer is basically only arithmetic operations. Yeah, so addition, subtraction, multiplication, and division. Yeah. So basically what we are going to do here is to translate, yeah, the problems in mechanical engineering into very simple calculation in which it can be performed by computer. Yeah. So that is the difference with calculus. Yeah. So we will going there. Yeah. So we'll see yeah, in detail about this course. Yeah, so we will see the explanation. Yeah, all of your answers are getting there. But yeah, still the question is, what is the difference with calculus? That should be answered. Yeah. Okay, so before we go there, so this is the course, yeah, of numerical analysis. So the basis will be the engineering mathematics as well. So it is supposed that you have a basic knowledge of calculus, yeah, although this will be different, yeah, and also a very basic knowledge of computer programming, yeah. So if you have taken computer programming or algorithm in second semester and you have taken engineering mathematics as well, so I think there will be no problem for you to continue on this course. And this course is more simple than engineering mathematics, yeah. So we are dealing with methods in which the methods is actually simple, yeah. So simplifying a complex problem that we will see in engineering, yeah. So that for the marking, yeah, so we will have some marking points for this course, yeah. So we will have class activities. So it means that I will take notes of your activity during the course, yeah. It means during the class we will have discussions, we will have questions and answer, yeah, during the course. So I will make notes of your name, yeah, and that will become the marking for class activities. And also we will have assignments, yeah, quizzes, midterm exam and final exam. And for the quizzes, we will see later, but it can be interchanged. Yeah, we can substitute that with projects. So usually in my class, yeah, we will have project. Yeah, not a very complex project, but quite simple project. And this project will use MATLAB. Yeah. So have you heard MATLAB before?
Yes, ma'am.
Yes.
Yes.
Okay, so we have the license for MATLAB. Yeah, we have the license for MATLAB. ETS has a license, and you can download MATLAB directly. Yeah, so when you go into the website, the MATLAB website, and then you insert your formal email address of ITS. Yeah, so then you can download directly MATLAB, and you can install it in your computer or your laptop. Yeah. So we will utilize a bit of MATLAB, and yeah, MATLAB is a little bit higher in programming. Yeah, so a little bit higher level language of programming, so that there are many functions already available in MATLAB. Yeah, so if previously you learned about Python before, yeah, so yeah, almost similar to MATLAB, yeah, and also the language is also sometimes interchangeable in between Python and MATLAB, so that I think there will be no problem for you to do some basic programming in MATLAB as well. Yeah. All right, so this is the rules in the class. So stop me when you do not understand, particularly because this is in English, so that I hope that you can understand my speaking. Yeah. And also if I'm going too fast, you can stop me and ask me to repeat. Yeah. Or even, for example, ask me to explain it in Indonesia, that will be fine as well. And please ask when you have questions. And I hope this class will be interactive. I want you to speak and discuss, yeah. And please drop the class if your mid-exam result is E, yeah, so that we will have a midterm exam, and make sure that you pass, you have a mark beyond 40, yeah, so not lower than 40. And as in ETS regulation, that no, you cannot absent for more than 3 times, and please make notes. Yeah, please make notes. Although we do this online, I expect that you still have notes or sketchbook or something to write down what we have done here. Although, yeah, the slides, the lecture notes or the slides will be uploaded through Classroom, so you can access it later. Yeah, I will upload the material, the slides of the class in Classroom. And if I'm forgot, yeah, if I forgot, please remind me, yeah, because sometimes I forgot to upload it, so please remind me. Okay, so this is the reference book from Chapra and Canale. So this is the compulsory book. Yeah, the title is Numerical Methods for Engineers. This is 6th edition. I think what I got is the 7th edition, but you can use any. Yeah, more or less the same. So this is the reference book. You can find it by Googling it. Yeah, I think it's very easy to download it. And this is quite a thick book. Yeah, about perhaps 700 pages. Yeah, and we will not discuss all of the material there, but yeah, we have quite dense topic to be discussed. Yeah, so that this is compulsory for you to have this book. And if you have difficulties to find this book, I can share it to you. Yeah, I can share it to you through the group. Okay, so this is the book, and this is a very nice book. So at least you have one book. Yeah, you will be okay. Yeah, but if you want to find another book, that will be better as well. Yeah, so in general, yeah, in general, what is the learning outcomes? What are the learning outcomes from this course? It is expected that you will be understand and you will be able to use numerical method to solve the equations and engineering problems. And it is expected that you will be able to use software packages in numerical methods. So at least a very simple program, yeah, constructing a very simple program to solve problems, yeah, using numerical methods. So this is the learning outcomes, and we will talk later what are the topics that we are going to discuss for the whole semester. Now, the question is why we need to study this? Yeah. Why we need to study this? This is not the core course of, or the main course in mechanical engineering. Yeah. Perhaps you have a main course such as metallurgy, statics, fluid mechanics, heat transfer. Yeah, those are main courses in mechanical engineering. But numerical analysis, yeah, this is not the main core. Yeah, the main course in mechanical engineering. But why this is important?
Excuse me, I want to try to answer.
Yes, Sultan.
I think we need to study this because as an engineer, we will deal with any problems, any actual problems that it's very difficult and very rude. And when we study the basic rule of engineering, we just we only could calculating and analyze a simple tragedy, a simple engineering problem. But in actual problem is very difficult. So we need to do numerical analysis to simplifying, to make the untuk mendekatkan kayak mempermudah kita memecah masalah yang ada di kondisi aktual gitu Bu, kalau menurut saya.
Yeah, so that is correct. Yeah, jadi betul. Yeah, so that is correct. So most of the real problem, yeah, the engineering problems are complex problem. Yeah, complex problem. So how can we solve these problems? How to get the solutions? So the main goal is to get the solution. Yeah, so this is the main goal. Now, when we want to solve this one, so what we need is we need to have the theoretical background in which this is supported by the main courses, yeah, by the main courses in mechanical engineering. So for example, you need to find the highest stress in the beam, for example. So those based on statistics and so on, statics and so on, yeah. Perhaps you need a knowledge on metallurgy, what is the allowable yield stress, for example. So those based to solve that, so this will be the main courses which give an equations. Yeah, so there will be an equations, yeah, or the governing equations. Yeah, so we have a governing equations from the main courses. Yeah, so this is becomes the theoretical background. So that this governing equation needs to be solved, yeah, in order to get the solution that we want. Yeah. Now there are several approaches to solve this. Yeah. One way is using analytical. Yeah. So that, for example, say I want to find the integration of, for example, x dx. Yeah. Sorry. From A to B, for example. So if we have these equations to calculate, for example, then we use analytical solutions so that we end up to have a basic knowledge in calculus of how to integrate these equations. Yeah. So based on calculus, we will say that, okay, the integration will be half squared x to the limit of from A to B. Yeah. I think you learned this already. So then we get the solution here. So this will be the solution. So analytical, which is a calculus. But the limitation is that sometimes this equation is not very simple as that one. So it's very difficult to do the integration. Yeah, we have separating variables, we have substitutions of variables and so on to do the integration. If this is very difficult function, for example, very complex function, so it's not very easy to integrate using calculus. So what other approach that is available here? So that will be numerical method. So what is numerical method? It's basically simplifying this one. So say we want to do the integration, so we don't need to have knowledge of how to do this integration. Yeah, so that we approaching another way, yeah, to get the integration. So what is integration is actually this is a, so say if we have a graph, yeah, so that the integration will be the area underneath. So that as long as we achieve the goal that we have the area underneath of the curve, we can use any method without knowing how to do the integration. Yeah, so that is the example. So that with numerical, we do simplification. Yeah, we do simplification so that we don't need to have an exact knowledge of how to do the integration, but such, for example, we divide it into discrete value, for example, here. Yeah, and then we add together this area so that we get the total area. So that will be the integration. Yeah. So this is numerical method. Yeah, is based on approximation. Yeah. So this is based on approximation. So what is approximation? So it's not an actual solution. Yeah, it's not an actual solution. So with this approximation, then we got the solution. So what is meant by approximation? Approximation means that we approximate or we predict the value. Yeah, so not the real value that we got from here, yeah, in calculus, but we use a method in which we can simplify the problem and then we got the approximated value. And if we talk about approximation, then it is very logical, yeah, if there can be a difference between the approximate and the analytical value, or we can say the exact value. Yeah. So there can be a difference between the exact value and the approximated value. And what is the difference here? So this is called an error. Yeah. So that when we learn about this method, we should remember that this method is about approximation, so that it will always have an error in the calculation. Okay. So now if there is an error, so why we need to learn about this? Yeah. Back again, this calculus or analytical solution is very limited to very, very simple problem. So most of the real problems will fall into here. Yeah. So then we have to use approximations to solve it. So now the problem is how to do the approximation. Yeah, how to do the approximation. So that is dealing with method. Yeah. So this is what we are going to learn. Yeah, we are going to learn about what method available to do the approximation. And the most important thing is that we have to know the level of accuracy. Yeah. How can we rely on the solution that we have from numerical methods? Yeah. How large is the error? So that will be the main thing to be discussed in this course. Yeah. So then when we talk about method, we not only learn about what method available, how is the procedure, how is the algorithm, how is the flowchart, but also we always calculate the error. Yeah, how much is the error? Is it acceptable or not? Or on another way, if we have three options of method to be chosen, which method that you want to use, yeah, so that we have to evaluate the error which is introduced by the three methods, for example. Yeah, so by evaluating the error, so that we can choose the best method for our case, yeah, to solve the problem. Okay, so this is to give you a big picture, yeah, of why we need to learn this one. Although perhaps you think that this is just a supporting course, yeah. So this is not the main course, but if you look at the trend at the moment, yeah, almost every calculation now is approximated by numerical methods. Yeah. Okay, so based on that, yeah, it is becoming important for you to understand the background, yeah, or why we need to learn this course. Yeah. So we see here that numerical method is widely used in engineering. Yeah, the reason is that we have mathematical modeling. Yeah, we use mathematical modeling to describe and predict the behavior of the system. So we can combine data with equations in here. Yeah, and also here we have the analytical solution, or what we can calculate from calculus, are only possible and complete for simple problems. Yeah, simple problems mean the geometry will be simple, also the properties should be simple, and so on. So very difficult to solve the real problem using analytical solutions. Now also because we see now computers are getting faster, yeah, uh, getting more powerful, yeah, so that it's an alternative, yeah, which is used in many disciplines at the moment, yeah. And powerful software packages are also available, yeah, so that it's increasingly important for us to learn numerical methods. So these are a few applications of numerical methods. We can use it in structural, mechanical analysis, design, and behavior, such as answered before, that is relates to finite element methods. So later, if you are interested in analyzing structural design, yeah, so finite element methods is also based on numerical methods. And also about communication and power, we have network simulation, traffic networks, train control, and so on. And also CFD, yeah. So CFD has many applications for fluid and also heat transfer, yeah. We can use that for weather prediction, groundwater, and pollutant movement. So these are only a few of the application. And if you see the book, yeah, I will later explain about the structure of the book, yeah. So the book will have a case study in which it will be applied to engineering problems. So there will be electrical engineering problem, mechanical engineering problem, chemical engineering problem, yeah. So we have many disciplines that utilize numerical analysis. So this is the example, yeah, in which we can see contour here, a distribution of the stress, for example. So this is basically utilizing numerical method in which, as said before, we discretize the domain here into small volume or small element, yeah, in which then for each of the element or the volume, we can find the stress, yeah, value, so that we can get the distribution for the whole domain. And also, for example, here we have gear, yeah, and also, for example, to find the temperature distribution, yeah, and also to calculate, yeah, for weather prediction, yeah, weather forecast, yeah, weather forecast. For example, predicting the direction of the wind, the temperature, and so on. Yeah, and also we can use this in combustion as well, yeah, fluid flow and so on. So many applications, and my research is basically on CFD, yeah, CFD. So yes, it is based on numerical methods. And once you understand about numerical analysis, you will have the grasp of CFD and finite element method, hopefully. Okay. So yeah. So next, what is yours? Yeah. You can be interested to study more in numerical method. Yeah, we have elective courses. We have finite element method, metode matriks untuk analisa struktur. We have metode komputasi fluida, CFD. Yeah, so if you're interested in that, yeah, hopefully this will give you a basis. And although if you are not doing any simulation, yeah, this course will be also useful for you to post-process the data that you get from experiment. Yeah. So for example, you get data from experiments, and then you want to find the trend line, yeah, or the regression. So this also based on numerical method. Okay, so that is a brief overview of what our course. Now here I will go deeper into the introduction for this course. So this is in part 1 in the book. So if you have the book already, yeah, you can see there that the book is divided into several parts. So I will show you the book first. Okay, so this is the book. My book is for 7th edition. Perhaps you can find the newer edition as well in the web. Yeah, not sure whether this is the last edition. So if you see here, so this is the book. Very nice book. It contains a very complete exercises. Yeah. So when we talk about numerical method, because this is dealing with methods, so it's basically a practice, yeah, a practice, so that we need to really do some practice on the calculation here. The method is not difficult, but yes, we need to do practice. Okay, so here you can see the bookmarks of the book on the left one here. So we have cover, title, and so on. So we have part 1, part 2, 3, 4, 5, 6, 7, 8. Yeah, and then we have the appendices at the back. Yeah, so that we will look at here that part 1 here. Yeah, part 1 will contain several chapters. So we have chapter 1, chapters 2, 3, and 4. Yeah, and then part 2 here is basically about roots of equations, and we have chapter 5, 6, and 7. So actually 5, 6, and 7 here shows the methods available. So you can see here the title is bracketing methods, open methods, roots of polynomial, and at the last chapter here we have case studies. So this is the practice. Yeah, so the practice is compiled in a separate chapter. Although each chapter here will also have a practice problem. So you see here that this part consists of one topics, yeah, which is roots of equation, and then it will have several chapters. So if we look at here, we have many part. Yeah, part 3 is about set of linear algebra equation. Part 4. So if you see part 8, the last one is up to chapter 32. So we have many chapters, but I don't. Yeah. So don't be confused of that. Yeah, these chapters are the methods available. So when you look at this, look at the part. Yeah. So the part will be the main topic. Yeah, the main topic, and the chapter will be the breakdown of the methods available for each part. Yeah. So if you look at here, we have a total of 32 chapter in the book, and the pages, yeah, about more than 900 pages for this book. So very thick book. Yeah, it is a complete book. So if you have this book, I think that will be enough. Yeah. Okay. So that not all of this will be discussed in this course, and I will share the syllabus later, yeah, through the classroom, so you can see what chapters, what parts that we are going to discuss, yeah, because we have many parts here, and it's impossible if you want to cover it only in one semester, yeah. Okay, so that is a bit about the book, yeah. Any questions before I continue? No? Okay. Right. So this is a review of what we have discussed. Yeah. So why we need to study numerical methods. So numerical analysis is basically a discipline. Yeah. A discipline. It's a course. We need to understand the concept and the theory, but this is not difficult. Yeah. Not difficult. The main thing is that with understanding the concept and theory, we know what problems can be solved and what problems cannot be solved, and when problems will be troublesome. So we will see that some problem will be easily to be solved. Yeah, another problem might be quite difficult to solve, and also a problem which has no solution. Yeah, which has no solution. So that we will learn about that as well. So perhaps if you remember about calculus, yeah, when you learn about matrix, yeah, you have learned matrix before, yeah. And you know that when we have a matrix have a condition number. Do you still remember a condition number? Yeah, heard of it before, yeah, but forget what is it, yeah. So a matrix will have a condition number. So actually a condition number means that are representing how easy the system to be solved, yeah. So for example, if the condition number close to 1, yeah, for example, so that the problem is easy to be solved. While if we have a very high condition number, yeah, for a matrix, it means that the matrix is ill condition. Ill condition. Ill itu apa? Sakit ya. Nah, artinya apa? It's not easy to get the solution. Ya. Hampir tidak ada penyelesaiannya atau tidak ada unique solution. Nah, itu artinya yeah, it means that some problems can be solved easily, while the other problems, because of the nature itself, is rather difficult to be solved. And why we need to learn this? Because we need to understand the method and the techniques. Yeah, we have many methods there, as what we've seen in the book. Yeah, and also the most important thing here is that we should be able to evaluate the error, the convergence, and the stability of the arithmetic approximation. So what is an error? An error?
Maybe it is the difference between the real value and then the approximation value.
Yes, correct. Yeah, Adim. Yeah. So error is the difference between the approximate value and the real value or the actual value. Now we will learn later that error is not only relative, yeah, to the that's only the difference between the real value, but also we have a relative error, yeah, in which we can comparing the error between one calculation and the other calculations, yeah. And next, about convergence. What is convergence? What is the meaning of convergence? Convergent.
As the answer, I think the convergence is about the true, I'm sorry, in Indonesia I say kebenaran yang dihitung. Jadi kalau misalnya ada hasil gitu, itu yang bisa diterima gitu.
Ada hasil yang bisa diterima. Bagaimana syarat dari hasil itu bisa diterima?
Kembali lagi dikomparasikan dengan apa namanya teori yang sebenarnya.
Berarti dikaitkan dengan error, ya?
Iya.
Oke. Masih belum tepat? Masih belum tepat. Kalau dikaitkan dengan itu, maka itu yang disebut sebagai accuracy atau keakuratan, ya. Keakuratan. Convergence is different with accuracy. So a solution which is converged is not always accurate. Yeah, a solution which is converged is not always accurate. So this is something different. Yeah, convergent.
I think the convergence is about the precision. So if we have an iteration, maybe if I use a method and then I iterate the method and then I have a convergent value, like the value between the iteration is not so far and then is converged.
Yes. Okay, so that is correct. Yeah, so you going that way. Yeah, so that's correct. So convergence means that if you have several calculations or several iterations, then the result will give about approximately the same solution. Yeah, so it's getting into one number, for example. Yeah, so when you proceed with the iteration, it's approaching to a certain number. Yeah, approaching to a certain number. But that number is not always accurate. Yeah, but it's approaching to a value, approaching to a unique solution. So that is called convergence. Yeah, so it's different between convergence and accurate. Yeah. What about stability?
Excuse me, ma'am.
Yes,
I would like to answer. I think stability means the resistance to change fluctuation.
Okay, yeah, so this is dealing with the fluctuation. Yeah, so this is correct. Yeah, stable if the calculation is not fluctuating in terms of the value. Yeah, so for example, we want to find the stress, yeah, in some points, and then the stress is not fluctuating. Yeah, so it's said to be stable. But sometimes it's fluctuating, so we call it to be unstable. Yeah, so this is the stability of the calculation when it progresses, yeah, from the iterations to another iterations. Yeah, so that is correct. Yeah, so this is what the parameter. Yes, these are the parameters that we will consider. Yeah, when we learn about numerical method. Is it convergence already? Yeah, or is it diverge? Yeah, diverge is the opposite of converge. Diverge means that the results when it progresses, yeah, so the value changes a lot. Yeah, so it's not leading to, it's not getting into one single value. Yeah, but it's keep changing the value during the iterations, sometimes high value, sometimes low, and so on. So it's getting diverge. Yeah, and so that this is a progress of the calculations. Yeah, while the error itself is more relates to the accuracy of the calculation. Yeah. Okay, so that those are the parameters, and we will learn about that. And also why we need to learn this, because this is an art. Yeah. So what is an art? So because this is an approximate, it means that it's not there is no method which is called the correct method and which one is not correct method. So every method is basically open to be used. Yeah. So it's not always obvious. For example, we have one case, it's not always obvious which one is the best method. So that here we have to have like some feeling to use one of the method. Yeah. And as you have experience on that, if you have experience on practicing solving the problem, so that you will have the feeling of which one will give the best method. Yeah, will be the optimum method to be used. Which method will give the best accuracy? Which method will be stable? Which method will be converged, and so on. Yeah, so that it's not always easy to choose. Yeah, which method will be the best. Yeah, so that because it's not always easy so that we are going to evaluate the precision and accuracy. So I think you have mentioned this before, Anggito, yeah? We have mentioned about precision, yeah, precision and accuracy. So precision and accuracy is different, yeah. Precise is not the same to accurate. Yeah, I think accurate is very clear. So if you have a calculation, the solution of a calculation in which the error is small, yeah, if the error is small, it means that is accurate. So it means high accuracy, high accuracy, very accurate. Yeah, but precision is different. Yeah, as have been said before, precision is when we have several attempts to get the solutions. So precision means that it always get into the same value. Yeah. So this is not related to the error, but during the attempt, it always yields to almost the same value, although the value may not be very accurate. Yeah. So precision and accuracy is different. And I hope that with this, you understand the difference, yeah, and that you can see how to evaluate that in the method. Okay, so that numerical analysis, yes, it's about mathematics, but it's different to what you have learned in mechanical mathematics engineering, ya. Matematika rekayasa, kalkulus sedikit berbeda, lebih sulit kalkulus dan matematika rekayasa, ya. Jadi lebih sulit. Ya, biasanya mata kuliah analisa numerik ini nilainya bagus-bagus begitu ya. Mudah-mudahan ini juga bagus semua. Ya, jadi memang lebih mudah. Basicnya adalah algorithm, method, procedure, ya, procedure that we will apply and then we got the approximate value. And the advantage of this is that numerical analysis, although it's approaching using very simple procedure, very simple calculation, but this method will be able to handle very large system of equations. It can handle nonlinearities, complicated geometries, and solving engineering problems which have no analytical solutions. Yeah. So this what we are going to learn for the whole semester. So we have first about the Taylor theorem. Ada yang pernah dengar?
I was in mechanical and fluid mechanics.
Yeah, in fluid mechanics, yeah. About Taylor theorem, Dirac Taylor, ya. Jadi tentang Dirac Taylor. Sebetulnya sebelum itu, you've learned this in calculus as well, ya. In calculus, you've learned about series, ya. Taylor series is one of the series, Dirac, ya, Dirac Taylor. And we will utilize the Taylor theorem here to simplify complex equation that we have. Yeah. And also we will learn about number representation. Yeah. Why this is important? If you were in my class in computer programming or algorithm, you might have learned this before. Yeah. So I was giving a bit about number representation in the computer. Why we need to learn this? Because we basically numerical method will be applied in computers, so that when we talk about error, when we talk about error, so that we need to understand how computer storing a number, storing a number. So there can be a round of error relates to the number representation. And what we are going to learn will be the solution of non-linear equations. So the roots of equations, you know the roots of equation, roots akar ya. Jadi akar-akar persamaan. Sudah tahu ya akar-akar persamaan? Ya, biasanya kita mencari kalau persamaan kuadratik itu X1, 2 sama dengan bagaimana rumusnya? Bagaimana mencari akar persamaan kuadratik?
Mau coba jawab, Mem?
Ya.
Yang ini minus B
ya.
plus minus akar
minus,
itu D per 4. Per 2.
Ya, per 2. Ya. So that is the example of root equation. But that equation is the equation that you obtain from calculus. Yeah. So what is basically roots of equation is that you find the value in which the y value will be equal to 0. Yeah. So you will find the point of the curve will intersect with an axis. Yeah. To the horizontal line. So that equation is basically from calculus, but here we will use other methods, to find the roots of equations. So that we want to find x1 and x2, but not using that regular equation that you have before. Yeah. So the main goal is the same, but the method is different. And then also interpolations. Yeah. So this is the very simple. You have to some interpolation in finding properties in thermodynamics. Yeah. So if you, for example, you have a pressure and temperature, for example, but it's not fall exactly in the data in the table. So that what you have to do is to do interpolation. And what you usually do is linear interpolation. Now here we will learn about other interpolation method in which we can increase it to higher degree of accuracy for the interpolation. It means that we will not use only a linear line to interpolate, but then we can use quadratic line, cubical line, and so on. Yeah, higher order, fourth order, fifth order. Yeah, to approximate the value in between two values which already known. And also we will learn about numerical differentiation. Now I think you have learned before differentiation. Yeah, for example, you want to find a value. Yeah, for example, we have y is equals to x, so that the differentiation of dy over dx, the derivatives of y will be 1, for example. So that is what we have from calculus. But we will see here that we will have other method to solve for the differentiation and also for integration, such as what I have told you before in the front of the course here, today. And this will be discussed up to the midterm exam. And after the midterm exam, then we will learn about the linear equations, set of linear equations. So this is dealing with matrix, a system, which can be represented by a matrix, and then we can solve for that to obtain the solution. And we also learn about curve fitting, curve fitting ini trend line, mencari trend line. And then also about ordinary differential equation and partial differential equations. Yeah, so these are the topic that we will discuss throughout the course. Yeah, and we see that there are quite lots of topic that we discuss, but as the course progresses, you will see that all of this will be solved using simple method. Simple method. So it's nothing difficult on this. Okay, so this is an overview of what we are going to learn. The first one is about roots of equations. So the roots is basically a value which fall into fx equals to 0. So that will be the intersection between the curve line with an x-axis. So everything will have fx equal to 0, so that will be the roots. In this case, we have only one roots, yeah. But for example, if we have parabolic, yeah, parabolic, so sometimes we can have 1 or 2, yeah, if it's a maximum or minimum. Okay, so we will try to solve that using numerical methods and also set of linear algebra. Yeah, we will learn this after the midterm exam. So basically, if we have two linear equations, for example, here, we have two equations to solve for two unknowns. Yeah, for example, here. So we have equation 1, which is a11x1 plus a12x2 equals to b1. So this will be the first line. And the second line is a21x1 plus a22x2 equals to b2. So this will be the second line. So that the solution for this, yeah, two equations to find two unknowns. So the solution will be the value of x1 and x2, which satisfy equations. So that will be the intersection between the two linear lines. Yeah. Now, what if we have three equations? Three equations to find three unknowns. So we can construct the matrix, yeah? And then we can find the value of x1 and x2 and x3. What if, for example, we have 10,000 to 10,000, 10,000 equations to find 10,000 unknowns? So that means we have a large system, and how to solve that? So we will learn that in numerical methods. So when we, for example, when we talk about finite element method, yeah, in which, for example, we divide a domain into small domain to get the distribution of the stress, for example, yeah, we want to find the stresses in each of the points here, yeah, or the volume or the element here. So that it means that one equation here will depends, one point here will depends on the neighboring, yeah. So it means that one equation will be used to define one element. So that if we, for example, have 10,000 elements, so it means that we will have 10,000 of equations to find the unknowns here. And how to solve that? And how to solve that? So we will discuss in numerical method. Yeah. Now this is the applications, calculus of structures, electric circuit, supply networks, state of course, etc. Yeah, and optimization, I think we don't discuss about that, and fitting curves, yeah, curve fitting. So we will do regressions and yeah, also interpolations. Now this is actually you can do it very easy in Excel, yeah. So you can do regression, for example, in Excel. But how Excel works, so that is what we are going to learn. Yeah, how can Excel do regression? Yeah, it's basically based on numerical method as well. And also integration, such as this one, yeah, finding the area underneath the curve. So this is, we can do this using calculus, but if we have complex equation for the curve, yeah, so it's very difficult to do the integration. So what we can do is we can applying numerical method to simplify it. And also ordinary differential equations. Do you remember what is ODE? So we have ODE and PDE. So what is the difference between ODE and PDE? Ordinary differential equations, while PDE is partial differential equations. So when we talk about differential, it means that we have derivatives. Yeah? Differential means we have derivative terms. So what is the derivative terms here? So this is the derivative term. So we have the first derivative of y in t. So dy over dt, that will be equals to f, a function of t and y, in which dy over dt here is also representing the slope. Yeah. So if you look at here, for example, we have a graph and we have a slope at ti. So this slope is dy over dt. So this is called ordinary differential equation, and we will solve this one. Yeah. So later you will see that there are two types of problem. We can have the initial value problem or the boundary value problem. So we will learn about that again. Yeah. So this is partial differential equations, and this is the formulation, the example, yeah, in which we have del squared u over del x squared plus del squared u over del y squared. That will be equals to the function of x and y. So this is called PDE. So what is the difference between PDE and ODE? So if we have differential equations, basically we have two ODE and PDE. So what is the difference? Ordinary means it's only a function of one parameter. Yeah. So the dependent parameter will be only a function of a single independent parameter. Yeah. So for example, we have y as a function of t. So y is only a function of t. While PDE, when we have, for example, a value, yeah, for example, u, which is dependent, which is a function of two independent variable. So this is called PDE. So that when we have ODE, because this is only a function of t, so that when we talk about the derivative, so the derivative is only, it can be represented with only one derivative, so only dy over dt. But with PDE, because u is a function of two variables, so when we talk about the derivative, we cannot just say the du over dx, but now we use the term of del u over del x. And this is not complete because it will have another derivative, which is del u over del y. Yeah, so this is the difference. And do you remember what is the problem here? When you find partial differential equations? Yeah, we have learned this in fluid mechanics. Yeah, so when we talk about the partial differential approach for fluid mechanics, you have found this one. Yeah, the partial differential equation in terms of del. So when you see del here, it means partial differential equations. And later, now you are in 5th semester, you will also learn about heat transfer. You will also see that the heat transfer problem, yeah, is also partial differential equations problem, yeah, partial differential problem. Okay. So that this, we will learn a bit on this, a little bit of introduction in PDE, in which this will be the basis for finite difference or finite element method, yeah, or finite volume method. Okay, so those are the topics in general that we are going to learn for the whole semester, yeah. And I hope that it can make you more motivated. Hopefully not demotivated, yeah, but more motivated to learn. Yeah. Okay, any questions before I continue?
Excuse me, ma'am.
Yes.
I'm a little bit confused about the difference between stability and convergence. If convergence means when we iterating some mathematical problems, when we iterating the another one, the value, the result is not far away, the difference. But the difference between the convergence and stability, I still a little bit confused about that because stability is mean not fluctuating, right? But when we talk about convergence, it's always not stable because the iterating value will be like Yeah, like fluctuating. So it's still different about those problems.
Okay, so stability and convergence, what is the difference? Yeah, stable, yeah. Stable, it means that the calculation is not fluctuating. Yeah. So for example, here we have the iteration, for example, yeah. And then we have, for example, the error. Yeah. So that we measure on the error for each of the iteration, for example, so that if the calculation is unstable, so that it will fluctuating. Yeah. Perhaps like this. Or it can be decreasing. Yeah, the error can be decreasing, but it's fluctuating. Yeah. So this is dealing with stability. Yeah. So it's fluctuating, it means that the calculation is unstable. Yeah. While the error might be in general going down. Yeah. So that is dealing with stability. So this is dealing with fluctuation. Now, what about the convergence? Yeah. The convergence means that if we have the value, for example, that yields to the same value. So we can also use the error, but this one perhaps I just took one value, for example, temperature. Yeah. So for example, I do some calculation and I got the temperature, for example, during the calculation. Sorry, this is iteration. So that when we have the temperature that going to into one single value here, so this is called converge. Yeah. So the value with the iteration is going to one value. Yeah. Or for example, if we measure the temperature as this one, yeah, it's a little bit fluctuating. Yeah. So it's a little bit unstable, but it's converging. Yeah. Unstable, but converging. Yeah. It can be as well. Unstable, but converging. But we can also have a stable calculation, which is diverging. Yeah. So in this case, I will use an error. The error, for example, here. It is stable, but diverging. So for example, when we do the iteration, the error keeps increasing, and then it stops because it will have, for example, infinite value. The calculation cannot proceed. Yeah. So this is stable, but diverge. We say that to be diverge. So it means it will have no solution. Yeah, so this is called diverge. So it means that stability and convergence is slightly different. Yeah, stability, when we have keep fluctuating value, yeah, it can be in terms of the value itself, the scalar value that we want to find, yeah, or also the error that we measure. Yeah, it can be fluctuating. Convergence means yielding to one value which is the same, while here divergence, or the opposite of convergence, yeah, it means that the error is keep increasing and the value is not getting into one same solution. Yeah, so the value is not getting into one solution. So the for example, the temperature, for example, if we measure the temperature, for example, yeah, so the temperature will not be physically uh, logical. Yeah, the temperature will not be physically logical. So usually this will have a limitation that the infinite value. Yeah, infinite value that is as a result from the calculations. Yeah, so this is called diverge. Okay, so there is a little bit of explanation between stability and convergence. Yeah.
Oh, okay. Thank you, man.
So later we will do some practices on that, and you will also do some iterations so that later you will understand when the calculation diverge. Yeah, so we have an error which is increasing and increasing. Yeah. All right. Okay, so I will continue on here about the mathematical model and engineering problem solving. So actually we have discussed that before, yeah, in which we have the mathematical model here. So this is actually the governing equation, which is supported from the theory and the data that we have, yeah. So that in able to do the analysis, yeah, or do some implementation here for the result, we need to have a problem solving tool. So numerical method is here, yeah. So it's, yeah, side by side with statistics. So you will learn later about statistic and experiment, yeah. So that it will be more or less almost similar. So those are the alternative methods that are available to solve for the governing equations that we have. Yeah. So that with these problem solving tools, we can have a result in which we can do the analysis and implement it. So that here, if we look at the general mathematical model, you see all of the equations that we have in engineering. So it's basically a dependent variable, yeah, as a function of independent variable. And we have parameters, yeah, some parameters and forcing functions. So I think you know already dependence. So this is a value which depends on the independent value. Yeah, independent value is the free value. Yeah, so this is dimension such as time, space, along which the system behavior is being determined. So this is the independent value. And also we have the parameters. So this is dealing with the coefficients that we have for the independent variables. Yeah, so this is reflects the system properties or the composition, the weighing of the independent variables. Yeah. And also we have the forcing functions. So this can be as a force, a source term, or the sink term. Yeah. This represents the external influences acting upon the system. Yeah. So this is basically a formula or a relations, yeah, from the engineering problem. Now we will look at the mathematical model here, in which we have a parachutist, yeah, in which a person will jump. Yeah, this is not a person; it's a bird. Yeah, we jumped, and then it will release the parachute so that it will cause, it will produce drag force. Yeah, it produces drag force, in which it will be reducing the acceleration, the gravitational acceleration. Yeah, so that to analyze for this, we should use dynamics equations. Yeah, so that we use the second Newton law. Yeah, second Newton law. So sigma F will be equal to m times a. I think you know this already from physics. Yeah, and a, so that a, the accelerations, yeah, will be F divided by the mass. Yeah, and a itself here is dv over dt. Yeah, so acceleration is the change of velocity in time. Yeah, so we can write down a as dv over dt, while F itself is sigma F, so that we have to draw the forces on the free body diagram here. So we have two sort of forces. We have the upper forces, which is caused by the drag force, and we have D here, FD is down force. Down force here caused by the weight, yeah, because of the gravitational accelerations. So that here we have FD plus FU, in which FD here is positive going downwards. So we give an example, a reference in which if it's positive, it's going down. Yeah, so positive is going down. So then we have F down, so that will be mg minus cv. Yeah, so here the upper force here is simplified. Yeah, is simplified with c times v. So c here is the drag coefficient. So you see here that this is a very, very rough calculation. Yeah, so drag force is not this one. Yeah, actually, yeah. So if you remember drag force, that should be cd time. Still remember?
half CD times rho
Yes.
times area times velocity power 2.
Yes, correct. Yeah. So CD times half rho v squared, the dynamic pressure times the area, which is the area is the frontal area. Yeah. So this should be the drag force. But here, yeah, we are not talking about fluid mechanics. Yeah. So here is simplified with C which is coefficient drag, and phi here is only a linear approach. Yeah. So it's not quadratic here like that, like it's supposed to be, but here we simplify it. Okay. So this is just to show you how we approach this calculation in analytical solution or using numerical methods, so that we have these equations, so that if we want to find phi as a function of t, so that what we can do is we do the same as what we have learned before, so that we have g over m. Yeah, so this will be crossed by that one. So g over m minus cv over m dt. Yeah. So then how to get phi t, so that we do the integration, yeah, from t0 to t, yeah, initial is t0 and then up to time t, and then the velocity initial is 0 up to phi. So that here we have phi minus 0, so that will be, yeah, we do the integration of that, yeah, and then here we have phi as well, yeah, so that phi, we have phi, so that should be not like that, they should be moved to the left one, yeah, because we have phi and we have d phi over here, so phi should be moved to the left one. So looking at this is already quite complicated, yeah, so then we end up with ln phi and so on, because this will be over sub 1 over phi, so that we have ln phi and so on, so that we have e exponential equation here. So I will not discuss on how to obtain that, yeah, that will be very calculus, yeah, very mathematics, so that the result is here. And you see this is quite already complicated. So how can we approach this one to get phi t, yeah, phi as a function of t using numerical method? So we will use an approximate solution here, which is called the Euler methods, or this is called the forward scheme. We will later learn more detail about this scheme, yeah. But this is just to show you that this is very simple. So when we see here, so that we have delta phi over delta t, so that will be g over, sorry, this is not over m, yeah, so it be g, so that will be g minus c phi over m, yeah, so that we have this one, and then we substitute delta phi with phi t plus 1 minus phi t over delta t will be t plus 1 minus at t, ti, yeah, ti plus 1, sorry, so this should be ti. This should be ti. So then when we substitute delta phi over delta t with this one, yeah, and then we bring that to the right hand side here, so that ti plus 1 minus ti, we bring that to the right hand side, yeah, and then we have phi t here is assumed to be phi ti, so that we have phi ti plus 1, this one moved to the right hand side, so that we have equals to phi ti plus g minus c over m phi ti times delta t. So this is actually delta t. So if we want to calculate phi at the subsequent time, so that will be equals to the velocity at the previous time step plus g minus c over m times the velocity at the previous time step times delta t. Yeah, so as easy as that. So we don't have the equation here, we don't have the continuous function, which is this is the real solution, yeah, the actual solution. But what we have is data points here, in which this is an approximated, these are approximated value. Yeah. Okay, so we will try on inserting the value here. So for example, this is the person, the parachutist. The mass is 68.1 kilogram. Yeah, and we have the velocity. We want to find the velocity, which is initially 0. Yeah, and then we want to find every 2 seconds after that. Yeah, every second. So to find at t equals to 2 seconds, 4 seconds, 6 seconds, and so on. And here we use the drag coefficient value of 12.5 kilograms per second. Yeah, and tabulate your values. So here with the actual solution, the analytical solution from calculus. So this is the equation that we have. Yeah, so we have a continuous curve. Yeah, a continuous curve in which we can tabulate the value here. Yeah, so that we have the velocity for each of the time there. Yeah, so this is called this is the function, the velocity as a function of time. Now, what about the approximated value or the numerical value here? So that, yeah, we do a very simple approach for dv over dt. So that is substituted with delta phi over delta t. Yeah, and this is delta phi over delta t. So that we rearrange the equation so that we have the new value on the left and the old value all on the right hand side. So that what we have is here, if we want to calculate the new value so that it is equal to the old value plus the slope of the equations multiplied by the step size or delta t. So that we see here that there is a difference, of course, because actually the slope is dv over dt, but we approximate the slope with delta phi over delta t. So there is a change. So we see here that, for example, if we have this graph, yeah, so this is the real slope of the function, while what we approximated here is this one. Yeah, so this is the approximated slope, so delta phi over delta t. So there is a difference of slope there. Yeah. So then if we do the calculation from each time step, yeah, so for t equals to 0, so the velocity is 0, so that we use that existing value to calculate the value afterwards. So here, for example, we want to find the velocity at 2 seconds, so that the new value will be the old value, which is 0, plus the slope times the velocity is 0, times delta t, which is 2 minus 0, so that the result here at 2 seconds will be 19.6. And so on. We can calculate at t for second from the value that we have in 2 seconds here. So that we have at 4 seconds, the velocity at 2 seconds is 19.6 plus the slope times delta t, which is 4 minus 2. So this is the new value that we have for 4 seconds, which is 32 meters per second. So that if we plot the value here, yeah, so that we have a function of velocity, yeah, in time, yeah. So here we have the exact or the analytical solution represented with the continuous curve, and here we have the numerical solution result, in which we have the data points here, which is calculated from the calculation or the time marching of the numerical method. Yeah, so if we see here, yeah, so this is the numerical solution, we see that there is a difference, yeah. So this is the error. Yeah, so for example, we have a point at 4 seconds. So this will be the error. Yeah, so the difference between the numerical solution, yeah, to the real solution, and this is the error. Now the problem is how large is the error, yeah, and how can we minimize the error? So looking at this, yeah, we can imagine if you want to make this point closer to the actual solution, so there will be one way to improve it, yeah. So we see here that we have a slope here. if, for example, we can reduce the slope, for example, a bit, so that we have this point, for example, yeah, we reduce a slope a bit so that these points will be closer to the actual solution. So this is one way that we can do to minimize the error. Yeah, changing the slope. Or the other way, perhaps to decreasing the time step. Yeah. So for example, here we do the calculation every 2 seconds. Now, what if, for example, we reduce it to 1 second? It may reducing the error in the slope. Yeah. So that when it projected to the new value, it is getting closer to the actual value. So this is basically what we are going to learn. Yeah. So we have a method, a simplified method for calculating a complex problem. And here we're using a simple algorithm, but then we have to figure out which one will give the lowest error, yeah, and how to minimize it. Yeah. So that will be the goal in this course. Yeah. So understanding the method and how to minimize the error. Okay, so I think, yeah. So I think that will be for today. Before we continue again next week, yes, because this is still the first meeting. So I think we need to warm up a bit, yeah. Okay, any question? Okay, yeah, if there is no questions, yeah, I think we can end this course. Now, please prepare for the book, or yeah, I can share it to you. Yeah, you already set up the group, yeah. Oh yes, okay, already got the group. Now I will share the book through the group. Yeah, the book, yeah, through the group, and yeah, you can prepare, yeah, for next week. We are going to still on part 1, yeah, still on part 1 next week. Okay, any questions?
Ma'am, I want to ask some question. It is if the problem is really complex, then we don't have the analytical solution. So how we calculate the error, ma'am?
Yeah, this is a very good question. Yeah, and this is commonly found. Yeah, what if we don't have the analytical solution, and what if we don't have the experimental solution, experimental data? Yeah, so one way to compare is using analytical solution or experimental data, but unfortunately sometimes both are not available. Yeah, so in that case, what we can do, yeah, what we can do is to compare with another method. So comparing it numerically. Yeah. So then later we will have an error which is said to be relative error. Yeah, relative error. So relative error is comparing the result from the calculation with another calculations. Yeah, although this is not a substitute for the actual error. Yeah, so not a substitute for the absolute error, but it is one way that we can do, yeah, to try to minimize the error. Yeah, I think that will be the answer.
Oh, okay. Oh, thank you.
Yeah, and we will learn about that later. Yeah, about how to calculate the relative error.
Ma'am, can I ask a question?
Yes.
Does that mean in that condition we can only calculate the precision, not the accuracy of the data?
Yes. Yeah. So yeah. Yeah, it is correct. Yeah, so if we don't have the analytical solution or we don't have the experiment yet, we cannot calculate the real accuracy. Yeah, the real accuracy. So that, yeah, in that case, not really the precision. Yeah, it's not really the precision, but we will learn later that numerical method will have several parameters, several parameters that are affecting the accuracy. So that later we will learn as well, that some parameters are affecting the accuracy, some parameters are affecting the convergence. So if we know some parameters that affecting the accuracy, so that we can try to use a method which minimize the level of absolute error. But yes, it is correct. So if we don't have those data, so that the absolute error cannot be calculated. Yeah, so I think that will be the answer. But it's not only precision. Precision correct. But if we can we can choose some method in which it will reducing the error. So the precision itself will lead to a closer value to the real value. Although we cannot measure it directly. I think that will be the answer.
Thank you.
Okay, Farhan. Okay, is there any other question? Okay, so if not, I think I will close this class. Thank you. And next week, inshallah, we will start on 9:45. We will try a bit whether you still able to start early. If it's not permitted, so then we can later adjust it. Okay, thank you, and wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Thank you, ma'am. Thank you, ma'am.
Excuse me, ma'am, for the presency for today.
I forgot. Presensi. Tadi sudah 41 kelihatannya, jadi saya centang aja untuk hari ini. Saya lupa tadi nampilkan sudah. Oke. Nggak masalah, nanti saya centang aja semua. Terima kasih sudah diingatkan.
Thank you, ma'am.
Thank you, ma'am.